Human civilization has put immense pressure on the wildlife and the ecology of the planet. Our mad rush to industrialize, fueled by bloody arms races and the irresistible pull of economic growth, have created a world scarred by mines and material waste, with all manner of pollutants having been carelessly dispersed into the environment. Two compounds in particular are of relevance to today's news. In the course of extracting metals from a mining site, waste is generated, like the mine tailings that are the waste products of chemical processes used to extract metals from their surrounding minerals. Among these waste products found in the mine tailings is radium-226. When we began testing fissile nuclear weapons, these man-made nuclear detonations spread various harmful chemicals into the atmosphere and the waterways near the test sites. One of these man-made chemicals is strontium-90. Now, both radium-226 and strontium-90 are radioactive isotopes. They are unstable and they'll decay, giving off some kind of radiation that can harm living organisms nearby. Even though we produced these chemicals through our industry and weapons testing, we are not immune to their dangers. When an environment becomes polluted with these radioactive isotopes, humans and everything else nearby can be put at risk. Cleaning up these pollutants can be extremely challenging, not just because of the inherent dangers of handling radioactive materials, but because they're often dispersed in the waterways. They're diluted and spread out over huge areas, which makes it extremely difficult to clean it all up. Now, amid these gloomy, damning facts, there is a ray of hope. A new study conducted by researchers at MIT and the Sorbonne University in Paris identified the bacteria species Gloeomargarita lithophora as being able to consume these radioactive isotopes and sequester them inside their bodies. The bacteria does this by preferentially utilizing these radioactive isotopes in some of their various metabolic processes, instead of using other, safer, more traditional chemicals. For example, the G. lithophora bacteria absorbs calcium to create calcium carbonate globules that it holds inside of its body. And when you look at these bacteria under a microscope, you can see these globules. They look like small little airsoft pellets or little white spheres inside their body. But when the G. lithophora is exposed to strontium-90 and radium-226, it will actually preferentially absorb these radioactive isotopes and integrate them into the carbonate granules. When the researchers studied the efficacy of the absorptive process, they observed that living populations of G. lithophora could remove as much as 99% of these radioactive isotopes from their habitat. 99%! That's incredible! I mean, that is mind-boggling, especially when you consider that the other tested bacteria could only remove 25% of the strontium-90 and only 14% of the radium-226. In addition, the researchers tested the G. lithophora's absorptive capacity when they were exposed to very high concentrations of external calcium. The test here being if the concentration gradient of the calcium was super high, if the bacteria would still preferentially absorb the strontium and the radium. And surprisingly, they did. They would preferentially absorb those radioactive isotopes over the calcium, even if they were exposed to a huge quantity of bioavailable calcium. As the researchers say in their abstract, quote, "The unique ability of G. lithophora to uptake strontium-90 and radium-226 at high rates makes it an attractive candidate for further studies involving bioremediation of these radionuclides," unquote. Now this is really exciting, because bioremediation techniques have proven to be some of the cheaper and simultaneously more effective methods of cleaning up pollutants. You basically let some giant microbial population engage with the pollutants on a chemical level, either metabolizing them into something that's not harmful or by sequestering the dispersed chemical into a more concentrated format, where the pollutant can then be manually cleaned up with much less effort. This discovery about G. lithophora, it's so cool, because it presents us with a really wonderful opportunity. We now have a powerful biological tool to clean up some of these radioactive pollutants in our waterways, which have been created by some of our most environmentally damaging and morally insidious activities. This opportunity, this bacteria, offers a glimmer of hope for a cleaner and more ecologically tolerable future.